So let's go over to Audacity now. And we see a blank screen. So let's talk through what we just looked at. If you go to the preferences here, this will take us to some of the parameters that we just went over, such as we could set up the devices. Core Audio this is a Macintosh, so Core Audio is the primary host that we'll be working with. And I mentioned to you that we could be using the built-in output, or we'll be using Soundflower a little bit later. But I also have this Inbox Pro, which is plugged into the computer through a USB connection, and that gives me somewhat better access to better microphones that I can plug into. That's why I'm using it today. So I'm going to be setting Inbox Pro as my playback device, and then also that will be my input device as well. So for recording, I'll set that, and I have it set to mono. You can see that I've got 8 channels on the Inbox Pro that I can specify, but right now we'll just set to channel 1 on mono. So then playback, you've got some other variables here that have the preview on the effects processing. We can specify different links for that. We won't have to set too many of these at the moment. Quality here again, we can change this from 44,000 samples per second into 48 or 96, as I mentioned before. You don't want to go too much lower than that. 32,000 samples. What you're going to be getting is you're going to be reducing the amount of information that is recorded into that. So some of your upper partial material will not be represented as clearly in that. And what that means is we'll hear most of the music, but we will be changing the timbre. Because remember, in our early lectures, we talked about how important it is that our ears can hear up to 20,000 hertz approximately, maybe 16 to 20,000 hertz. So the reason you've got to have 44, and this is something we'll talk a little bit about later, which has to do with the Nyquist theorem, which if you have a waveform, each waveform, because there's a compression and a rarefaction, you have to have at least 2 samples per cycle in order to represent that cycle. So in order to hear up to 20,000 hertz, we would need at least 40,000 samples in order to make sure that all the frequencies up through our hearing range are represented in the digital conversion. So that's why 44 was set as kind of a standard. So if you go higher, obviously you're getting a better representation of each of the higher frequencies. So higher is always better, but for our purposes, 44 is kind of efficient for what we're trying to do at the moment. So we'll leave it set there. And 24-bit is fine for what we're doing here. We eventually could go higher than that. Interface, most of these things I don't think you'll have to do much changing to. We'll come back to these later. Setting how the spectrograms will be handled. And then these are, when we get into the effects processing, there will be some effects processors that come with Audacity when you buy or download the program. It's a free program, you don't have to buy it. But you can also use effects processors that come with, for example, Macintosh. You have the audio unit, which are effects processors that will be embedded, that will be accessible by Audacity. And then a VST, or another set of ones that you can download from various third-party vendors. Many of these are free on the internet as well. So if you can download VST effects and put them into the correct folder, then Audacity will be able to access those. When I go into my effects processing, I'll show you a lot of the ones that I have internally are ones that I've downloaded or come with commercial programs that are not part of the Audacity initial load. But you're welcome to try out downloading other ones as well. And then some other specifications for about some of the commands for keyboard. And so that's essentially what's in the preferences. So what we've got here is the Core Audio to getting our inboxes set. The Inbox Pro, which we had set up in the preferences, is set up here. And then the microphone is also Input Pro, and then the mono. So with that, we should be ready to record. And one of the things that, before we record audio, let me show you under the drop-down tools here. The generate, effect, and analyze are the 3 sort of effects groups that we'll be working with. So you see here these top ones, chirp, DTMF, tones, noise, silence, tone, as well as click track, the pluck, the recé drum. All of these are ones that will have different purposes, but we probably should go through and take a look at those. Let me go back for a second, go back to Safari. Remember I said if we go back to our main page for Safari, to the front page, we can go over to finding the correct effect. If we do that, it will take us into various categories of the effects generators and analyzers. So that's part of what we'll be doing, is looking through here are an alphabetical index of all the effects that come with Audacity, and you can see that's a pretty robust set of applications that you can work with even before you try to download other ones. And what's great about this particular tutorial is they organize them in functions. So once we learn to record sound into Audacity, I'm going to go through each of these different categories of effects functions and explain maybe one or two of most of them, and then ask you to, on your own, go back through the other ones that I don't show. But it should be a similar kind of process for you to try to go through and look at each one of these to understand what they're doing. And there's plenty of information to describe them in the tutorials here, but I think it's worth your time to go through each of these. There are 13 categories of effects here, and so if you can do one or two beyond what I do in each of these, then I think you'll really understand all the options when you start to get into doing your own sound design and editing. So now let's go back over to Audacity and let's see if we can just try a couple of generate for a second. So chirp, for example, this we can do is a generator of just a short example of a waveform. And remember we talked about earlier the different kind of waveforms. The sine wave is a fundamental with no partials, and you remember the square wave is a type of pulse wave, which is a fundamental with odd numbered partials and an amplitude relationship of 1 over n. The sawtooth is a fundamental frequency with all partials in an amplitude relationship of 1 over n. So these are the three that we could generate. So let's just try to sine wave for a moment, and if we click on this, then you will see the sine wave in a decreasing or ascending format here. And so then if we listen to this just by hitting the space bar, so you can see from that what I was showing up here on the output levels, I became the level of the loudest signal here, which this is showing the loudest amplitude, was pretty close to 0 dB, so that way I was not getting distortion, and as the pitch goes higher it was reducing down in volume, so the amplitude was going down. So if you want to get rid of this, you can either click the X here or you could just hit delete on your keyboard and the track goes away. So let's just go ahead and click delete that. Another generation, we could have these are signals that are similar to what your telephone generates. So if I wanted to type in a phone number or something, let me just type in a couple of numbers here. So you can sort of hear the similar. These are just 8 numbers. What it will do, it will trigger, just like a phone does, a multi-timbral, multi-tone sequence for that. So you'll see here that then if I listen to this. So these will be used for purposes later on, but that's what these generators are for. The ones that we'll be using perhaps more than that would be the click track, for example. Many times if you have a composition where you need to have a steady beat measured, you can quickly generate your click track as the sort of starting track. So we see here, generate track. We can set up how many beats per minute. So 120 beats per minute would be about, well, is 1 beat every half second. And we can slow that down or speed it up here as well. We can go all the way up to 292 or down to 30 beats. So we could do 1 per second at 60. And then you could set up, it will give you accents on every, if you want to do measures. So in this case, we've got a 4-beat measure. Then how many measures it will generate. You can do up to 1,000 measures at once for the click track, and so forth, so forth. Yeah, we'll get to these a little bit later. You can change the sound. The default sound is a ping sound, but you can make it a noise or a tick sound. So with that, and eventually we could get a MIDI pitch to change that as well. So let's just generate a click track and just see what that looks like. And you see here, if we listen to that, it's 1 click per second. And we get a different sound every 4 beats because we specified this would be a 4-beat measure. So this is often good to start out. And you could, when I hit my space bar to stop, if you want to not hear that during the composition, you can just hit the mute button, and then when you play the tracks, obviously you'll not hear that. So the click track is a very useful generator device. Delete that. We can also, we'll come back to some of these others. You'll see here are some of the VSTs that I've downloaded. Some of these are from third-party vendors like the Motu Mach 5, Reactor, which is also a commercial program. These you will not see in your list. You should see most of these up here as well, because these are all part of the generator list in Audacity. So then we get to effects. Once we record something, then these will be not just yellow or opaque. They will show up once we get something recorded, as well as analyzed. So these are the ones we're going to be working through once we get something recorded. But let's go ahead and record some audio now. Over here, it's very simple to record audio. If you just click the record button, it automatically will make a track and will start recording the sound into it. So I'm just going to click that and then record my voice, just counting some numbers, and then we can work from that and sort of play around with it. Testing, testing, 1, 2, 3, 4, 5, 6, 7, 8, 9. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I recorded some sound, and you see here it created a WAV file from here to the end. Now, up here, I can zoom into this. For example, going back to my tool, which is the selection tool, if I want to click and drag on my selection tool, you see I can highlight whatever I want. Nothing's happening yet. I'm just identifying a certain area that I could zoom into. If I hit my zoom command, it would then use that as the center, and it would allow me to keep zooming in closer and closer to that. And you start to see the individual waveforms as I zoom in more and more. You can eventually get down to individual waveforms, which I can just keep zooming in. But let's go back to the whole form here. And now you see the whole audio file is stretched out over the entire length of my screen. If I could do that, if I keep zooming back out, make it smaller. If I wanted to have this do that, all you got to do is click on the whole file. Up here, this one is to fit selection, and what it'll do, whatever you select, which was from here to there, will fit over the course of the entire screen. So you see now that allowed me just to kind of see it, the whole thing. This other one would be once you have a project, the whole project would be fit over your entire screen in one setting there. So up here we can see the timeline. That was about 18.5 seconds that I recorded here. And I mentioned to you the first thing that I like to do is to get rid of DC onset, is to normalize the file. So let's do our first effects processing. So if you wanted to, you can click and drag with your selection tool, or you could go up here to just select all, which is Apple A, which is a standard select command on most computers, or Command A. You can do the same thing. That selects the entire file. So from there, if I go up to effect, we can now move down to normalize. And here you've got just a couple of settings. So ask it to remove any DC offset, which I want to do. And then we can also have it normalize the maximum amplitude. What it's going to do is going to find the maximum amplitude and move it up to right below 0 dB, which in this case would be -1. If you don't want to go that high, if you think you might be recording something louder later, you could change that to a little bit lower. Or if you've got separate channels, you want to normalize those differently, you can collect this. On many of these effects processing, where it has to recalculate the whole wave file, such as this one, there will usually be a preview button on the effects. And it's sometimes good to listen to that first to see if that's exactly the effect you want before you hit OK. Once you hit OK, it will then recalculate the whole file, and you'll see the resultant graphic here. All these are non-destructive, meaning you can always redo. Remember the redo button up here, you can go backwards and undo what you just did, or redo here. So there's another command for that which you can use, which is Command Z or Apple Z. We'll take you back through the step through those. But let's just hit the previews, sort of see what that sounds like. And you'll see it. Testing. 1, 2, 3, 4, 5. Okay, sounds like it'll be fine. So let's go ahead and normalize this to -1 and get rid of any DC offset. Notice all the amplitudes got louder, because what it did, it brought the the amplitude level up to -1. So now we have everything normalized, and this does not add any kind of noise to the sound, and by getting rid of the DC offset, it should improve the sound in many cases significantly. So let's listen to see if you can tell any difference on this. Testing, testing, 1, 2, 3, 4. Probably can't tell too much difference there. It just sounds maybe a little bit louder. So normalize is often the first thing that I will do to a file before I start working with it and changing it around. All right, so many times after you have normalized the sound, you may want to then get rid of any extraneous. For example, in the beginning here you see there was about a second before I made any sound. I don't really need that silence perhaps. Maybe you want to start the sound file pretty close to where the first sound starts. And the same thing at the end. Perhaps this sound here I don't really need. There's a couple of ways you could do this to delete that. Using your selection tool, you could just do one separately, drag that amount, and then if you just do your standard cut, remember the standard cut, copy, paste are in place here. So if I go down to here, I can do the copying, or I can do the cut and get rid of it here. So remove audio, there's your cut, delete, so forth. So if you just do the Apple C, you could cut there. I could do the same thing at the end. Another way to do this is using the trim knob, or the trim button, which is here. So if I wanted to just select the area of sound that I'm interested in keeping, maybe from there to there, then once you have highlighted that, your trim function is engaged. If I hit the trim, what it's going to do is get rid of the sound on either side of this. So it'll just keep whatever sound that I've highlighted. So that's sometimes a more efficient way of doing that. When I hit the trim, then you see both those go away. And I've just left that. Now, if I wanted to move this sound back to 0 seconds, what I would have to do is to go into my time shift tool, and then I can move that toward the 0 seconds, or I can have it start at some point. I can actually have it start anytime after that. So, but I want to start at 0. Move back to the selection tool. So now when you hear it, testing, testing, 1, 2, 3, 4, 5, 6, 7, 8, 9. Testing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so I get rid of the sound before and after. I've normalized it as the second effect. Before we go on, let me just go back over to the manual and show you down to the different categories of effects so we can walk our way through that. I just want to show you a couple of them. Amplify is another way where you just essentially take everything up and amplify the effect. Be careful with this one. You can increase or decrease everything up, because you will be amplifying some of the sound at the extraneous sound you may not want, and that also you have to be careful that you don't get into any kind of clipping with that as well. Same thing too, the leveler effect makes quiet passages louder and loud passages quieter. It's similar to a compressor, but it does it in a little bit different way. And each of these you have to be careful with clipping. So normalize was the first one we did, which is make the sound louder or quieter. But I'd love you to explore these other ones on your own. So one of the other things, a lot of times you want to fade in or out, and there are different kind of fade in or out commands. So let's now go back over to the sound file, and let's say I wanted to fade in over this whole first section. Remember, this sound was testing. So if I just wanted to fade in over the first 2 testings, because that's where the numbers start there. So let's say I want to just fade in. I select that, go up to effect, and you'll see fade in. So fade in will automatically give you a linear fade in where the amplitude starts soft and gets louder and louder. Testing, testing. So now you can fade in over something, and then once you release that, testing, 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 testing. Oh, notice another function here. Once I had highlighted that, you can drag the highlight and it'll stay to as long as you want. Through testing, 1. So you can pull this arrow if you want to have temporary timing of that. Okay, so let's go ahead and do the whole file just for a moment. Now, so that was fade in.
The preceding program is copyrighted by Emory University.